Welcome student. In this numerical, 4 identical cells are connected in parallel as given in the connected with an external circuit having two 15 ohm resistors in parallel. In the terminal potential of each cell is equal to 1.6 volt. Calculate the internal resistance of the cell. First, this we will combine. First, we will find out EMF equivalent of the parallel combination, that is EMF of first one, this divided by this plus this divided by this plus this divided by this divided by this plus this divided by this divided by 1 by R plus 1 by R plus 1 by R plus 1 by R, that is the equivalent EMF of the 4 combination of parallel branches. So this is equal to 4 into E by R divided by 4 into 1 by R. So this 4 cancel, this cancel, is equal to E. So E equivalent. See, already we have proved that for n identical number of cells, the EMF of the equivalent circuit will be the EMF of a single cell where all the cells have the same EMF. And R equivalent. What about R equivalent? Equivalent R is 1 by R equivalent is equal to 1 by R equivalent is equal to 1 by R1 plus R1, R2, R3, R4 into 1 by R plus 1 by R plus 1 by R is equal to 4 into 1 by R is equal to 4 by R. 1 by R equivalent. R equivalent is equal to R by 4. This, all the 4 resistors are in parallel. To get this, take any one of the resistor divided by number of the resistor. This is the expression for R equivalent. So this can be, now we can write it as a single circuit. That is, it is having a EMF of equal to E equivalent is equal to E and R equivalent. R equivalent is equal to R equivalent is equal to R by 4. And this is external circuit. Since it is in parallel, this and this serves as a external circuit, external resistance, that is load resistance. This can be made, this parallel combination can be made as a parallel, that is R, that is R equivalent, that is R is equal to 15 into 15 divided by 15 plus 15 is equal to 225 and divided by 30, or otherwise, since both the resistors are same and in series, identical resistor in series, we can take any one of the resistor divided by number of the resistor. Both will give the same answer is equal to 7.5 ohm. So R equal to, so external resistor, this portion we have written as this, and this external resistor R is equal to 7.5 ohm. 7.5 ohm, where equivalent EMF for this 4 parallel circuit is equal to EMF of a single cell, that is single cell, and R equivalent is equal to R by 4. We have calculated. Now, since we have this one converted into this net EMF of the parallel combination is equal to E equivalent is equal to EMF of single cell, and the equivalent resistance is equal to R by 4, and this external resistance R is equal to 7.5 ohm we have written. Since that it is given the terminal potential of each cell is 1.6 volt, that is terminal potential of this cell, this cell, this cell, this is equal to 1.6 volt, that is terminal potential difference is equal to 1.6 volt. See, since it is combined, what is the equivalent? This one. This is equivalent. This also terminal potential. Since all are in parallel, that means the terminal potential of each cell is equal to terminal potential of the combined cell because it is in parallel. Or we can write, since the general expression for terminal potential is equal to EMF of the EMF minus I into drop across the internal resistance. Here in this case we can write terminal potential is equal to EMF. Here EMF is equal to E equivalent minus I. See, since current is flowing, current will flow like this. So it means current will flow like this. Current I into R equivalent. Simply we have to find out R equivalent. Already we have got R equivalent is equal to R by 4. Okay. R equivalent is equal to, if you bring this side, then E equivalent minus V divided by I. E divided by I, or I can be written, since, see, what is the potential across this one is equal to current through this into this external resistance or R. Suppose this is the potential across this one, same potential will exist here also, which is equal to terminal potential between this end, which is also equal to that potential difference across this point, which is nothing but I into R. So is equal to IR. Since here potential is equal to I into this R, or we can say E equivalent minus V. Since I is equal to, we can write V divided by R, or we can write it as R equivalent is equal to E equivalent. E equivalent, as it is, we know, EMF equivalent is equal to EMF of a single cell. E equivalent minus V divided by V into R. This R will go on the top, so it is equal to simply on off. Or which is equal to EMF is given. EMF, how much is EMF is given? 2. EMF of single bat is equal to 2 volt. Since EMF is equal to 2 volt, a terminal potential is equal to 1.6 volt. See, always terminal potential difference is EMF minus the drop across the internal resistances. So that's why the terminal potential will be less than the EMF of the given battery or combination of batteries. So this is equal to 2 minus V is equal to 1.6 divided by V, 1.6 into R. R is equal to this one. It's equal to R, which is equal to 7.5, which on calculation comes out to be 15 by 8 R equivalent. This is another one. As it is, R equivalent is equal to R by 4. R equivalent is equal to R by 4. Equating these two, R equivalent also equal to R by 4. Since we have to calculate the internal resistance. See, circuit having to in parallel, the terminal potential of each cell, calculate internal resistance. It means we have to join these two. That is, R by 4 is equal to 15 by 8. Cancelling this one 2. R internal resistance R is equal to 15 by 2 is equal to 7.5 ohm. Therefore, internal resistance of each cell is equal to R, which is equal to 7.5 ohm. So this is equal to R by 4. R is equal to 7.5. This we can verify by putting this equation, which is equal to 15 by 8. 15 by 8 is nothing but 7. So internal resistance is equal to 7.5 ohm. So R is equal to the internal resistance of the combination R is equal to 7.5 of each cells. This cell, all are identical cell, each having the internal resistance of 7.5 ohm.